Hi, I'm Rick Barron, and today in the RAF5 History of Neurology segment, I want to talk about early Italian neuroscience research, and I have subtitled this The Sparkling Italians in Translational Research. So I'll start with Giovanni Morgagni, who really was the father of modern anatomic pathology and autopsy. He was educated in Bologna, the first true Western university, founded in 1088. And he taught there he taught at University of Padua for 56 years. He wrote this amazing book called On the Seats and Causes of Diseases, in which he recorded dissections or autopsies in 646 patients. And he correlated this with their clinical symptoms and course. He emphasized the importance of basing diagnosis and prognosis and treatment on the pathologic anatomy. So this was really 5 books published in 2 large folios back then, but subsequently English translations put it in 3 volumes. And the important neurologic thing that he showed in these autopsies is that the site of the lesion in apoplexy or stroke was in the brain was on the opposite side of the body involved. A major discovery. So now let's get to the electrical Italians. So electricity. The term electricity was first coined by William Gilbert in the 1600s, the famous scientist in England. And then 100 years later, the Leyden jar was invented where electricity could be stored. And immediately after that, electricity started being used to treat people with paralysis and illness. This is very popular through the writings of John Wesley, who was not a physician, but who wrote a couple books on this treatment. He also ended up founding the Methodist Church, and also by Jean-Paul Marat, a famous French physician who wrote a lot on electrotherapy. He also happened to be one of the leaders of the Reign of Terror in the French Revolution. Ben Franklin, who was a leader in electricity, also was a little more reserved about his enthusiasm for using this for treatment of neurologic disorders. So along comes Volta and Galvani immediately after this. And Volta was a professor of physics at the University of Pavia for 40 years. He is considered the inventor of the electrical battery. For this, he was made a count by Napoleon in 1810. The volt is the standard international unit for the electrical potential, named after him. And he had this long disagreement with Galvani, who I'll get to in just a minute, about is there animal electricity or not. Galvani thought there was, Volta thought there wasn't. And he proved that electricity could be generated chemically, and it didn't require, did not need to be generated by living beings. So here is Volta's pile, or Volta's battery, this is what he used to refute Galvani's, some of Galvani's thoughts about animal electric fluid. But what he did is, Galvani published all these experiments in this book, which I'll show you in just a minute, and Volta went through and rechecked each one of them and came up with different ways of doing the experiments. It was pretty amazing. So he replaced the frog legs in Galvani's experiments with brine-soaked paper, showing that you didn't need the frog muscle. So now finally Galvani. Galvani was a physician, a physicist, a biologist. He was educated also in Bologna, like Morgagni, and he actually taught there his entire career. He is thought to be the discoverer of the concept of bioelectricity and the father of electrophysiology. In 1780, he showed that you can apply an electrical spark to a dead frog leg's muscle and it would twitch. And following this, he did numerous experiments with muscle and nerve preparations, and therefore he's rightly considered to be the originator of the concept that we can study electrical patterns and signals from biologic tissues. He thought there was animal electricity or a force in the muscle that generated the electricity. And this is the concept that Volta was rejecting. So here you can see not only his picture, but one of his examples where he used electrodes to stimulate frog muscle legs. Here is his research team working on a number of muscle and nerve preparations in frog and in other animals. And so he published this in the commentary on the effects of artificial electricity and on muscle motion. And this was originally published in Latin in 1791. And then it had these amazing pictures that I'll show you a couple here, these long fold-outs of his muscle and nerve preps. And so these are the experiments that Volta then tried to replicate. Most of them he did replicate it. The term the galvanometer, an instrument for detecting and measuring electrical current, is of course named after Galvani. He gave demonstrations of muscle stimulation to the lay public, so he gave tours to politicians and other investors, and here's a picture of that. And here is the lab, some of those long pull-out pictures from his book. He also did patio laboratory experiments. And here you can see his frog legs on a patio table hooked up to getting some electrical current from lightning. So I think he really can be considered the first Bill Gates doing experiments in his garage, essentially. So the sparkling Italians, Galvani and Volta, they really took basic science concepts of electricity in the 1600s and 1700s, and then they translated that to biomedical research and applications. So they should be considered some of our original translational scientists, and Galvani, I think, is the original EMGer. Thank you very much.